Hi everyone. My name is Pavel Shigelski, and it's really challenging to pronounce my surname in English. Even in Russian, it's a problem. But yeah, today we are not here to talk about my surname, but we're here to listen to our excellent speakers. And I want to say hello to everyone on the opposite side of the monitor who is watching us, who is joining our stream. Hi community, hi audience. Okay, GG Minsk continues the tradition with online meetups, and before we move forward, I want to get acquainted with you and introduce a bit what GG Minsk is. I'm very excited today, and would you mind if you wrote in the chat where you're from and say hello to your virtual neighbors? While you're replying, let me answer what GG Minsk is and who we are and where we are from. We are a Google Developers Group, and it's a community located in Belarus, in Minsk. The main goal of the community is, of course, networking, sharing knowledge and experience, talking about different technologies, not even necessarily about Google technologies, even if our community called Google Developers Group. And of course, meeting new people, expanding our social network and interaction. We do meetups and conferences as well, but usually we focus on three main streams. It's web, cloud, and mobile. So if you're interested in those subjects, you will always find something interesting at our meetups. How can you find GG Minsk and join our community? Basically, we are everywhere in all popular social networks like Facebook, like Telegram, and of course YouTube and Twitter. And I highly encourage you to check our YouTube channel for previous meetups. You will find there so many different topics. I hope that you will find something interesting and very informative for you, very nice for you. And of course we are online. That means that basically you can face some problems, some internet problems or any other problems, connection problems. Don't worry, we can help you there. Please contact us in the chat so we can help you there. Last but not least, we need your feedback, of course, to improve our meetups, to improve our stream. And every feedback helps us to move forward. So we kindly ask you to leave feedback after our meetup, because everything we do is for the community. Okay, that was a short intro about GG Minsk. I hope that you find something useful for you and you get acquainted with what does mean GGG and what does mean GG Minsk and who we are. And today we're going to have two presentations. Both speakers will present in English and both speakers will talk about security. It's really a combo today. And I'm really excited to hear the stories, to listen to the stories. And now we are ready to welcome our first speaker on the stage. Hi, Kamil. How are you?
Hello, everybody. Glad to be here. I'm well, and you?
Yeah, good. Thank you. What do you do on daily basis? Why do you like Formula One? I noticed that in your short bio that you like Formula One, and it's really interesting. Why do you like it, and who's the best?
All right, it's a good question. I think my story with Formula One started somewhere around 2007, maybe a little bit before, when Robert Kubica, I think the only Polish driver, was part of Formula One and was becoming this prominent star alongside Lewis Hamilton at the time. I'm originally from Poland. Currently live in UK, but Poland is in my heart. So being a fan of a Polish driver in Formula One was the thing that brought me in. Robert is still somehow in Formula One. He had bad luck and bad accident in the past. I think he had good spell last year or 2 years behind when he was a driver for Williams. Now he's still fighting to kind of come back to Formula One. So finger crossed that's going to happen. But yeah, that's the story about Formula One and why I like it so much. So
Yeah.
Hopefully,
Great,
we will see Robert again.
Me too, me too, me too. I'm not keen on Formula One, really. Sorry, but yeah, I can understand what you're talking about. Good, good. Okay, so then I don't want our audience to wait any longer. So maybe we can start our first presentation. Uh,
Awesome.
Let me share. Yeah, can you share the screen? Can you share your screen, and we'll start
Let's
with
do it. And can you see my screen now?
Yeah, yeah.
Awesome.
Yeah.
I'm just going to click present, and here we are.
Yeah. So I will leave the stage, and will wish you good luck and rock the stage. Then everything is yours. No.
Perfect. Thank you. Hello again, everybody. Thank you for having me in your meetup. My name is Kamil. This talk is going to be about unifying security testing between kind of security engineering requirements and to make sure that kind of developer experience it's there in that pair. There's going to be kind of side story of what Open Policy Agent is in action, and we're going to get into the details. Disclaimer, I'm not here to represent the company I'm working on at the moment, so opinions here are only my own. And I do work for a commercial product that is related to the topics in this conversation, so just bear that in mind. So who am I? My name is Kamil, like you know. I am security engineer by profession. My background is initially in offensive security. So I was a pentester, a hacker, a security researcher, and analyst for around 5 to 6 years, mainly focusing on testing security infrastructure in cloud environments. So anything around AWS, Kubernetes, Openstack was kind of my passion. After spending some of the time kind of breaking into the systems and feeling I kind of built up this passion towards these cloud technologies and wanted to become an engineer on the side of developing these systems. So I moved to become a cloud engineer to build kind of security controls and help protect these instead of breaking them. And currently I'm working for Snyk. Snyk is a security company that provides various products from open source security to cloud. And I work on an infrastructure as cloud product. So let's get started. Kind of, if we look from security point of view, our kind of North Star and objectives are to prevent misconfiguration in cloud environments. This talk is going to revolve around examples in Kubernetes as an example of kind of cloud environment, but we're going to touch on how that impacts things such as AWS or GCP as well. And what we want to do is to make sure that we enforce the kind of security policies or practices we want to ensure on all of the entry points. So from my background in offensive security, I kind of spent many years trying to look around the loopholes in the systems where we can find different way we can circumvent controls. So the North Star is that there isn't such paths where we can circumvent these decisions. And kind of the third big topic is we want to audit and any attempts to circumvent those controls. So as I was a pen tester for many years, there was a kind of a blue team on the other side, which being the people who monitor the systems for security intrusions, who try to attribute my behavior to certain things that I was doing. So from a North Star, we want to be able to prevent all of those things. And here in an example, you can see that we can use things such as kube control on a kind of CLI console to connect to a cluster. We can do that through pipelines such as Argo CD is a system that allows you to deploy dynamically things to the cluster with your configuration that's stored in a Git. And you can do this through cloud consoles as well. So when we're looking at it from kind of engineering point of view, the first idea that comes to mind is to block bad config in API. Logically speaking, if we can prevent this at the API layer, we can, on the server side, we can ensure that any and all API calls to that endpoint will be protected with the same policies. So as long as there isn't a vulnerability in the API itself, we can ensure that the bad configuration that we try to kind of push to the cluster will be prevented. So in Kubernetes world, we can introduce something called admission controllers. Admission controllers are basically webhooks that sit alongside API servers that validate requests based on certain criteria. So whenever you think about sending a request to an API server in Kubernetes, that API has a certain parameters. So if you want to deploy a pod or deployment specification, it will have certain features. It will say, for example, if the pod can run with privileged permissions, or if the pod can be running with UID 1000. And we can check for these things. We can have admission controller that listens to all of those requests, and whenever the request comes in, it validates our policies. We can write a policy that says the pod cannot be privileged. We check that, and if the admission controller defines that this request has the privileged pod, it says a deny to the API server, which then kind of rejects the request. So in order to show that in action, I have a demo environment over here. Hopefully you can see my font size. As you can see here, we have no pods in this simple cluster. But let's go and what can we do? And here I have an example of container that wants to run with privileged permissions. So as we can see here, there's a flag that says privilege true. And my Kubernetes cluster was configured with admission controller, and we get into details in a second what that admission controller is. And then we're gonna just try to deploy it. And then if everything works as expected, what you can see here is that we get a kind of deny message that says container must not run as privileged. This was prevented with admission controller. When we on a kind of console level access, this is quite fast feedback. So problem solved, right? So if we can do this, then everything is well and good. Well, let's see this in true action, right? So in production systems, you usually won't be deploying pods directly to the cluster, right? So in my example, I have a simple application. It's a Golang application that is deployed with Helm to Kubernetes cluster, and there is a Docker file that builds it. So let's try and change that configuration. So I have my configuration here. What we're gonna do is gonna just try to set it to true. I'm gonna commit it. In this example, I'm gonna commit it directly to my kind of release branch. Usually you should have kind of PR checks, but we're gonna get to that in a second, how that works. Attempt privileged pod. And always sign your commit. So that's why I need to enter my long password. I'm just gonna push it. Demo application. And what we should see here in a second, that our pipeline has been triggered. Now what this is gonna do is, we made a change. It's gonna take certain amount of time to go through all these steps. And these steps are build a container, validate that the code that we've written is correct, push it to ECR registry, and then notify our kind of application that something has to change. Argo CD monitors the repository at the same time, but we're gonna let the pipeline finish its job and notify it to update itself. It should take a minute-ish. While we're waiting, last time I ran this, it took around 3 minutes. But what you can see here is that the pipeline failed. We had the kind of admission controller prevent our access, and as you can see here, we get the same message that we got in the console, but in a PR. Now, this takes around 3 minutes-ish. In our production systems, our pipelines take from 5 to 10 minutes. They still considered fairly fast in terms of kind of deployment times. I've seen production systems that take 30 minutes to go from when you submitted your PR, it got approved and pushed. That is a very long delay between you making a change and getting kind of feedback that there is a potential misconfiguration that you're trying to do. Let's see if this is finished now. It's still building. So you see it's still we still have to wait to find out that something is going to be wrong. So problem is not really solved. Developers do not want to wait that long, and we as security engineers should not expect them to wait that long. So what can we do about this, right? So blocking API calls is frustrating to the callers. If you didn't know that someone has set up these kind of policies, that's even worse. It would be very surprising to you that you've pushed a fix to a breaking change, only to find out that at the end that the cluster has declined your new system to be deployed. So enter Open Policy Agent ecosystem. What is Open Policy Agent? It's a kind of collection of tools that allow you to write policies, whether these are security policies or kind of admission policies, authorization policies. They could be also linters. It's just up to you what you want to define as a policy in a kind of declarative way that has some functionality similar to policy, to kind of imperative language, but it allows you to focus on writing a policy logic and not thinking about, am I using correct sorting algorithm, or is my code efficient, or do I have infinite loops in my policy logic, which means my kind of admission controller will just be stuck in a loop trying to kind of understand what's policy doing, but there is just a bug in the logic, right? So that's why you want to use something like Rego. Rego is a language based off Datalog. It's not very well-known kind of language, but it's there to allow you to query structured data for specific logic purposes. Let's see if our pipeline has finally decided to tell us that it's finished. Still doing it. So demo gods are not with us today, but we can continue. What we saw so far is that we implemented something called Gatekeeper in our Kubernetes cluster. And it ended up at this end side of the story to enforce. This can often be implemented by security teams to make sure that we don't have misconfigurations. It's powered by Open Policy Agent. It's all of the policies that we apply are written in Rego, and we're going to see examples of them in a second. But the ecosystem allows us to move kind of left and all the way left to developer and the local CLI, and we're going to see that in action. In order to run CLI tools on Rego policies, we can use a tool called Conftest. Conftest is just a CLI tool that executes Rego against your configuration files. In order to help you develop these policies, there is good ecosystems of tools that allow you to debug these rules, show you what's going on. The language, when you start using it in the first place, might not be very user-friendly, I would say. But the kind of user-friendliness is there to prevent you shooting yourself in the foot. So, for example, you cannot do things such as recursive functions in Rego, just to make sure that your policy evaluation always ends. And finally, when you write these policies and validate them, you want to share them. And you want to share them between people, but you also want to share them between systems. So there is an amazing tool called Constraint that allows you to use single source of truth, such as a Rego source code, and kind of template it into both the rules that can be used by Conftest and CRDs, custom resource definitions, which what a Gatekeeper is using to kind of enforce things in the cluster. So let's get into some of the examples. Demagos are really not with us today. We want to write a rules once. So this is an example of a Rego policy. When you first time look at it, you might feel like it's a programming language, right? So there are packages which namespace your kind of logic into a package. You have imports, which means you can have composable code. You can have libraries that you can reuse pieces of that code. And there is something called rules, which are these statements. However, that's where the kind of language familiarities from other imperative languages such as Golang or Python kind of stop. When you see things such as functions with the same names, these implement kind of additive statements, meaning, or you could think about them, they implement kind of an or operation. In this example, what we want to express is that container is privileged is if either of these two cases are true. And then you can just call it once, and they kind of make up an if-else statement. And then within the rules, all of these operations are an AND operation. So all of these statements inside of here need to evaluate to true for us to get a positive feedback. There is way more to Rego as a language, so I will not go into details because we don't have that much time, but I would really like you to just go to the open source repositories and browse and see how that works. So we want to write it once. And then what we want to do, we want to generate these policies so that they can be reused by multiple things. And here we can use tool Constraint to create all of these policies. So in our example, what we did, we have this one policy called the one that we saw in the example before. We write just one. We use the Constraint tool to generate these CRDs, which look like this. If you're not familiar with Kubernetes, these are kind of very detailed. They operate such like Kubernetes objects, but they defined new types. And inside of them, what you can find here is the same source code that we saw in the source file that can be shared and reused by Kubernetes Gatekeeper. So that's how we generate them. And then we want to share them as code. So we want to reuse the principles that developers have been using for a long time. Historically, security teams were not adopting the same tooling that kind of developers did. So what we want to kind of show here that we can use Git to version control policies, share them with all of our company so they can see what we're trying to accomplish as security engineers, and they can provide the feedback, they can review it. They might want to introduce changes or exceptions and store them in a shared library. And then we want to validate things locally. So let's see how we can change the behavior that we saw initially. So what we're gonna do, we're gonna do something very bad that we should not be doing ever, but this is a demo repository, so that's okay. This, and in my repository, I have a pre-commit hook. Pre-commit hooks allow you to kind of run commands before you commit things into your Git repo. And in this pre-commit hook, what we're going to do, we're going to add a conf test call to pull the policy libraries that we have deployed into Gatekeeper from Git repository and execute them on our change. I'm just going to write this. So what we're going to do again, follow the same steps that we did before. Set this to privileged, which means our deployment, our pod will be running with privileges that we really shouldn't be giving to containers. Add it and try to commit it. And hopefully, if my demo gods are with me, and they are, what we can see here is we immediately get feedback, right? So we haven't committed anything into our Git history, and we have identified the exactly same problem that hopefully our demo was supposed to show us, but Git is not with us today. We would see that in order to bypass this step, we're just gonna sync it manually, because that's the only thing that has changed. And as you can see here, that's the admission hook. It would usually take a long time, but as what we can see here, even our Git repository is taking way longer than 2-3 minutes that we used before. So this is how we moved from, let's time this here. So we moved from 4 minutes that the demo should really take to 1.4 seconds in order to get the same information to the developer about what they're doing wrong. So that's a huge improvement. But if you're not using Git hooks, and if you don't want to remember that you need to run these things locally, then you can implement the same checks in your PR settings. So we can quickly demonstrate the same here. And then we're going to do punch. And what we're going to do is ignore our pre-commit hook. And then if we look at our, oh, here we go. It took 12 minutes this time, but that's great. We finally get it to finish. Thank you, GitHub. And right, let's create a PR. And then what we should see here in a second, we have our validation. And because I know, let's hope it's going to be faster this time. Right, as we can see here, our pipeline is telling us the same thing, and it only took 7 seconds. So still improvement. And with PR checks, when they version controlled and they need approval to change, you can ensure that you get the same kind of security practices back early on to your developers. So that's 7 seconds. And then what you want to do is to make sure that your gates are automatically deployed to your kind of enforcement system, your Gatekeeper. So for that reason, what we can demo very quickly is in my library, I have introduced, we're gonna add another control. And then I need to do this. All right. Prevent. Do that in production. And what we should see in our Argo CD, and if you look at applications, that this should pick up the changes. Yep. So you can see here our gate would pick up the changes magically. Now, I need to do it twice because I have a bug in Argo CD that I haven't figured out how to fix yet. So what we need to do is do this first. Synchronize. And now, in our command, what we're going to do is try to immediately make the same change, right? So we're going to go to deployment, and we're going to say host network true, which means we're going to have access to all of the networks of the node. And then we're going to try to commit that. Hopefully, as you can see here, and what's happening here? No, this is not what we want to do. So I'm going to make a trick. Demo gods do not like me today. Right. So what you can see here is we pushed it to central repository. We added additional check that is immediately enforced on the kind of gatekeeper level. But our developer, when they add new topic, immediately sees that the same check is enforced, and they get the feedback. They know they need to make a change. They know they need to do something in order to get that through the pipeline. So that's what you want to do. So what about our kind of cloud configuration? Can we use the same tool to help us with securing Terraform, for example, or Cloudformation? The answer is yes. As long as the data is structured, you can do it with Open Policy Agent, and this is an example of where we verify that security groups are secured. And then lastly, summary. So make sure you manage your policies as code. As we saw, just commit them to the central repository, manage them the same way like you would do your web applications, deploy policies automatically. So as we saw with the Gatekeeper, the policies was enforced in the cluster, and then validate code early on. Let developers get the feedback early so that they can make changes in the local environment. They don't have to wait like we did 12 minutes for a pipeline that took way too long to finish in order to make changes and fix potential misconfigurations. And what next? If you're interested in the Open Policy Agent, here is the kind of awesome set of kind of resources that include everything from policy libraries, where you can just get all of that security policy content prepared for you, so you don't have to start from scratch. The resources on how to use Open Policy Agent, SDKs, and whatever you could come up in your mind. And that's it for my presentation. If there's any questions, I will take them. I think we're running a little bit late because of the demo.
Yeah, good. Yeah, great. Thank you very much for your presentation and the live demo. By the way, yeah, it was nice. It was really nice. Yeah, Git likes you today.
I haven't prayed enough, so live demos are great, but as you see, we need to pray a lot to get them working.
Yeah, that's true. But nevertheless, it was really interesting to see these checks that we can do in order to save someone's life. Yeah. Okay. Good. So basically, yeah, that's. I forget to mention that after each presentation, we will have time, like 5 minutes, about 5 minutes for Q&A session. So if you have questions, you can ask it in the chat, and we will highlight it here. Like the first question, it's basically my question, because I'm also part of the audience and I would like to know something. So why Rego? Not any other language, Python or Go? And what are the pros and cons of using it?
That is an awesome question. We get that question a lot. Rego was designed to kind of to solve a specific problem, to query a kind of large set of data structures very fast and in a kind of fail-safe manner, right? So we cannot, you basically cannot shoot yourself in the foot because you kind of limited of what you can do. But that's done on purpose. You also don't have to worry about thinking, is my code efficient? Is my code definitely written in a correct way that will use the right sorting algorithms? Is it searching? Is it looping way too many times, right? The kind of you want to the creators of the language abstracted that to compilers, to the runtime, to ensure that it is effective. So you can focus on making your policies very declarative. Write them in a way that they can be readable by anybody, and also by anybody that might not be developer. People who maintain policies such as standards might not necessarily be developers. And they might not have skills such as yourselves with writing Go or Python or any programming language, and teaching them kind of limited constructs of OPA may be simpler and may be kind of shared with wider audience than just developers who then have, high background in, running code such as Go or Python. So that's a primary reason why would you want to select something like Rego.
Is it difficult to study, to start coding with Rego?
I like to say it depends. If you are a developer and you have spent many years coding in normal imperative language, it will take your brain a little bit time to adjust. So because it's constructed in a kind of different ways, the way you normally think about a code might lead you into thinking you know what you're doing, whereas you actually kind of, it's not how the language works. So, but if you are not a developer, then there is a lot of resources that are out there. The explanations are quite clear and you can get into the groove. But even I fall into that trap of thinking, oh, this looks somehow like Go, so I can just do it. And then it took me many nights of thinking, why is Rego doing it in this way than the other way? So there is pros and cons.
Yeah, okay, I see. Because I've never heard about this Rego language, really. It was something new for me. So, yeah.
I would say it's a niche language. I don't like, because you cannot write a web application in Rego. Okay, it is only limited to querying data sets for information that you want to find. So it's not what I expect everybody to be familiar with. That's my take on this.
Okay. Yeah, I see. Okay, and the next question regarding the security, this step protection. Can a tool such as static application security testing with SonarQube Developer Edition increase product protection?
Yeah, it's a good question. Any security tool that allows you to discover kind of security misconfiguration early will increase product protection, right? It will. However, there is a high cost sometimes you have to pay to it, right? So the SAST ecosystem of tools have been very bad in the past years on generating too much noise, noise to kind of positive results ratio, right? So if you are flooded with 1,000 issues, out of which maybe 2 or 3 are something that you really need to make secure and protected, then I would say the SAST tool at that point is counterproductive, right? Because you are putting effort in filtering out noise rather than finding issues. So it really depends if the tool is actually delivering on its promise of finding misconfiguration or security issues, whether they vulnerabilities, versus finding just potential things. So it's an if answer again, but hopefully there are products out there that are trying to think about creating things, providing less but more accurate results and not focusing on numbers.
Okay, I see. Okay, yeah, that's 2 questions. Basically, we can ask one more question, and one pops up in my mind. It's regarding how do you manage the exceptions?
Good question. So for everything, so sometimes some things might be misconfiguration. So the example we had in the topic was kind of having privileged containers. Generally, it's a bad practice. However, you will find applications that require that permission. Right? They will not operate without it. Right? So we need to be able to say, for this specific time, that's acceptable. So what you want to do is come up with the system that allows you to manage them centrally. So always in code. So the same way I showed you my library of policies, you would, for example, want to have an exception list in there that is managed as code. So for example, you as a developer would raise a PR saying for this rule, that's an exception. So we're not disabling the check. We're not saying that is invalid. We're only saying that we accept the risk. We accept that this is a elevated privileges, but we require it for our operations. So you're kind of accepting it, and it's there, so we can move on. So manage them as code, make them visible to everybody in your company, so they can be shared and distributed. And that's it. And Rego is very good at that. It allows you to kind of implement that in code and have various layers of exceptions for different developers.
Okay, I see. Okay, good, great. Thank you for your presentation. Yeah, it was really nice to see you and to see the live demo, because we do not I don't remember the last time when we do a live demo, but it was fun to see it. And yeah.
I love to watch me fail on the demos, so I'm never gonna stop doing them, but I like them too.
Yeah, live demo is always a very hard work, and but it's something always can happen. Yeah, but it's okay. But that's fine. So yeah, okay. So thank you very much. Let's say goodbye to you.
Perfect. Thank you for having me.
Our next. Yeah.
See you guys next time.
Yeah. Okay. So.